Now, next in the time independent system is pseudoplastic systems. Pseudoplastic systems have this type of rheogram, and this is the viscogram of pseudoplastic materials. If we see that rheogram starts from the point of origin, this again means with application of small stress there is strain produced. But this line is not straight. This means they are shear thinning systems. Their viscosity decreases on application of stress. If you see the viscogram, there is decrease in viscosity with application of stress. So for such systems, their viscosity decreases with application of stress. Now, if you take an example, we will just divide the graph into equal segments, and we will see that this is the first segment, this is the second segment, and this is the third segment. See, RPM is same in all the three. So it is 5, it is again 5, it is 5. So total is 15. RPM is same at the same RPM. In the first case, this much amount of stress is required. Say this is 5 and this is again 5, so 10. Later on, it is 2.5 and 2.5. Later on, for second segment, only this much amount of stress is required. And if you see the third, a small amount of stress is required. This exactly means that their viscosity is decreasing because less stress is required to produce same strain. Or you can say that small value of stress is producing a same strain. When it will produce the same strain? It will produce the same strain when viscosity is less. Therefore, slowly as stress increases, viscosity of these systems decreases, and they are called as shear thinning systems. This is also called as gel to sol conversion. So these systems are gel to sol converting systems. Now, since line is not straight, so they are denoted by modified equation called as Oswald-de-Welde equation, where s raised to the power n, which is constant, is equals to neta into g. This n is less than 1 for pseudoplastic systems, and lesser is the value, means n close to 0 shows that material is more shear thinning system. Fine. The examples of such materials are polymeric solutions, like solution of long chain polymers, cellulose, carbopol, carbomers, etc., and weakly flocculated suspensions. Now, first we take example of polymeric solutions. Now, in case of polymeric solutions, what happens when they are added to water? Because to attain minimum surface area, all polymer chains undergo coiling. So two forces act, coiling and hydrogen bonding, because of which they become viscous or gel-like. Fine. When stress is applied, slowly there is alignment of these coils because of or under influence of stress. So when stress increases, they align parallel to each other, coiling is opened up, there is no formation of hydrogen bonding, so bonds break down and open up, and flow becomes easy. Flow becomes easy means viscosity decreases, and hence such systems are called as shear thinning systems. This is also observed in weakly flocculated suspensions, because in weakly flocculated suspension there is formation of house of card arrangement, due to which the gel form is converted into a solution form, and therefore they are also termed as pseudoplastic systems. Pseudoplastic systems in their curve has a single curve. This is because they are time independent. When stress is removed, they immediately come back to its original position, and therefore there is no another curve, because both the curves are superimposable. Next time independent system to explain is dilatant system. Before moving on to a dilatant system, let us take a very common example of a pseudoplastic system, that is paints. See, you have seen a paint, it is thick when it comes, Then painter rotates it for several times. Slowly its viscosity decreases and easily it is applied on the walls because of the thinning effect. So pseudoplasticity is this conversion from high viscosity to lower viscosity. Just opposite to this, dilatant systems are shear thickening systems. Means for these materials, on application of stress, their viscosity will increase. So rheogram is characterized by this type of curve. If you divide the curve again into two halves, you will see, like again, I'll just divide the curve based on the stress. So we will keep this portion and this much portion here. What we will see the difference. On application of same stress, same amount of stress, so 0 to A is same, A to B is same. You will see that initially the G value or rate of shear is large. Then later on same stress, the rate of shear is less. Why this is less? Because viscosity of material is now more. I have told you the triangle relationship between stress, strain and viscosity. Therefore, these materials are characterized by this type of curve because on application of stress, their viscosity increases and they are called as shear thickening systems. Again, they start from point of origin. This means small stress will bring the change or motion in the material. This is the rheogram, this is the viscogram, which shows that on application of stress, there is increase in the viscosity. Now, the equation is again Ostwald-Welde equation, which is same as used for pseudoplastic material. Just n value for dilatant material is greater than 1. Rest all is same. Dilatancy, this property is shown by concentrated deflocculated suspension. A biggest example of this is concentrated deflocculated suspensions. First to take is a simple starch solution in water. So when you add starch to water, when you heat it, what happens? Solution is formed. On heating, suddenly this solution changes into gel. So this is called as shear thickening. Same thing happens to deflocculated suspensions. Particles are away. Since it is concentrated, so water is limited. When any force is added to this, these particles move quite away from each other, and due to limited water, their area expands. This is called as volume expansion, and because of the volume expansion, limited water, they becomes thick. Same thing happens when you take a wheat flour, add a small amount of water and mix it. On mixing, dough is formed. Dough has higher viscosity. Again, amount of water is very important. If you add a little bit, it will become liquid. So, only concentrated deflocculated suspensions show dilatancy. Dilatancy is also observed when we are using wheat flour along with water. Too much addition of water make it a liquid, but if appropriate, dough is formed. So this is the characteristics of dilatance. Dilatancy is exactly opposite to pseudoplasticity. Dilatancy is salt to gel conversion or shear thickening system.